Hey there. In this video, I'll be sharing one of my projects which I have made using Python language. Yes, as it is usual, I'll be sharing my Snake and Ladders terminal game. This project is basically not having much UI. It is basically running on the terminal, so we'll just run the code. First of all, let me share the objectives with you. We all have played a novel, simple snake and ladder game, but in this game, I've added other features also. Let me show you the features also. The feature of the game will be the board will be generated based on the user's choice. In this code, I will be providing the choice to the user to play on the board, which is of ranging from 5 to 5 dimensions, from 5 into 5 dimensions to 10 into 10 dimensions. Like it can be of 25 cells, 36 cells, 49 cells, 64 cells, 81 cells, and 100 cells. Second feature which I have added is any number of players can play this game. Yeah, it's not limited to a two-player game. It can be a multiplayer game also. Third feature which I have added is every time the board map will be new. Yes, position of snake and ladders, which will be randomly decided. So every time you refresh the game, every time you run the code, the board map will be new. It will never be same the last time it was. And the fourth important feature of our code is pathfinding and dash move recommendation. By the feature of pathfinding, it means you are currently present at position 5. You want you want to know that what your future moves should be so that you can easily win, like you can win faster as compared to the other competitors. So this feature will help you provide it. So this is the benefit of the feature. The feature can be quite helpful for players, making the game mode in a engaging and strategic. Moving on to the code part. Let's first start with the logic part. Uh, by the start part, it means we will be having the main. In the main, we will ask the user for the board choice, whichever he wants. We will generate the board according to the user's choice. Then we will generate random number of snakes and position them at random position in the board. Next, we will ask for the number of players which will be playing the game. We will initialize the players and bonus chances by default so that we can store the rows and column values of the players when he advances his location in the board, and bonus chances so that we can store if he gets any store the bonuses which he gets while playing the game. When he gets a bonus, he will get the bonus if he gets a six or if he climbs a ladder. Next, the main game loop part. In the main game loop, we will be running a infinite while loop which will end by a break statement. And that break statement will be passed until and unless we get a winner of our game. If we get a winner of the game, that break statement will be executed and the game will end. Inside this while loop, we will create a for loop whose range will be of the number of players so that every player gets his turn. Now, when we'll start the game, we will first check whether our player is present outside the board or inside the board. Because if the player is outside the board, then how can we advance his location inside the board? That's why we will first check whether it's outside or inside. If he is outside the board, we will roll the dice. And if the dice moves comes to be 1 or 6, we will land him on inside the board, move to the board, and we will check whether whether there is any ladder present at cell 1 or not, because a case might arise that in the board is generated in which the ladder tail is positioned directly at the first cell only. Then so to handle that case, we will let the player climb the ladder in his first move only. We will display the board. Okay, this is the case when the player will be outside the board. And for the case when the player will be inside our board, we will just directly roll the dice and we will check the new position, whichever the dice move come, we will add that to the player's current position. And then we will check whether the new position is within the range of our board, that it doesn't exceed the end cell value of our board. If it is, then we will advance the player on the dice roll. And if it isn't, like if a your current position is 23, and the max sell value is 25, and the new position which you are getting by adding the dice value is 27. Then we will display the message that sorry, you can't move any further. And moving on, advancing the player based on the dice rule. Now, while we advance the player on the dice roll, if the new position is having a ladder, so to check that condition, we'll be using the if statement to check whether there is a ladder or not. If in that new position, if there is, we will let the player climb the ladder, and if there is a snake, we will move the player token to the snake tail step. After that, we will check for the bonus chances which he has received by getting six or by climbing the ladders. If he has got the bonus chances, we will use those bonus chances by letting him roll the dice once again, giving him one more chance to roll the dice. After that, the main feature of our code, which is the shortest path, we will display the shortest path from his current position to the end so that he gets to know what his next cell value should be, next dice value should be, so that he can reach the end position faster as compared to the other players. After that, if we get the winner of our game, we will end and we will terminate this for and while loop, and we will end this program. So this was the logic part. What we'll be needing to create this code? We will be needing list, dictionaries. Why will we needing list? Because we are doing this program in Python. If we were supposed to do in Java or C, then we will be using arrays. But we are doing it in Python, so we'll be using list to create a two-dimensional array-like structure. And we'll be using a dictionary also so that we can store the positions, the rows and column position of the players in that dictionary. Now, what modules we're requiring? We're requiring a random module, OS and platform module, and a collection module. When I will be sharing the code, and I will tell why we need these many modules. So let me share the code. This is our code. It is of around 270 lines. Okay, let's first see the output of our code. Let's say we want a 5 into 5 dimension board. Number of players, let's say 2. Okay, so here's our board. Let's start our game. Okay, he didn't got 106, player 1. Next. Okay, player 2 got a 1, so he has entered our board. So here is the updated location of player 2. Now let's see for player 1. Okay, he hasn't got neither 1 or 6. And now player 2 got a 4, so he advances from cell 1 to cell 5. He has moved from cell 1 to cell 5 over here. Now, coming to the shortest path, which I was telling that what the shortest path, it will show him that the minimum number of moves, in what minimum number of moves he will be reaching the finishing line. So here you can see from 5, if from 5, the possible dice moves, which are 1, 2, 3, 5, 6. If he gets any of these, the shortest, see over there, if we add 1 to the 6, it will be 6, and 1 to the 5, it will be 6, then 7, then 8, then 9, and 10, and 11. So here in the shortest path, it is showing 19. There might be a ladder. That's why it's showing a 19. Yeah, there it is. See, LH1, which means ladder head 1, which means we have to find ladder tail 1. Yep, there it is, ladder tail 1. So, according to the shortest path, it is saying that from fifth position, he should climb the ladder at seventh position to position number 19. And after that, he should get a 6 so that he can reach the end position of the cell. So this is the feature which I was talking about, the shortest path. Okay, so this is the feature. Let's see for player number 1. Okay, player number 1 got a 3, so he's still outside our board, so we can't do anything. Player 2 got a 4. Okay, since player 2 got a 4, he will be moving from position number 5 to position number 9. So the positions are like changed. So now new shortest path will be created. The shortest path will be created at every turn. every time the player moves to the next position, it will inform the user that what his shortest path should be, what should be his next strategy to win the game. Okay, so here's the new shortest path for the player from his current position to the end position. See, from position 9, he should move to position number 13. After that, he should get a 6 so that uh, he can land on position number 19, and he should get another 6 so that he can land to the last cell. Why he should get 2 6? Why it is saying that the player should get 2 6 in a row? Because from position 9, you can see that there is no ladder available over here. So there is only 6 is the possible thing by which he can he can reach the endpoints faster and faster. So that's why it is recommending 6. Okay, and here is the next dice move recommendation, which is 4, so that he can land on the shortest path. See, his current position is 9, and the next shortest path cell recommendation is 13. So that's why his next dice move recommendation should is 4. Okay, let's see for the player 1. He's still outside our board. Player 2 advances to from cell 9 to cell 9. Okay, he got a 1. That's why. Okay, so the shortest path might also be changed. Okay, the shortest path is still the same. The change only happened is the dice move recommendation, which is from 4, it changed to 3. Okay, player 1 got a 2. Okay, player 2 again advances, got a 1, so it advances from cell 10 to cell 11. Let's see. Okay, player 1 still outside. Okay, player 2 got a 5. So from cell 1, he moves to cell number 16. Okay, from cell 1 to cell 16. From here, the shortest path will be he should go to cell number 19, and he should then get a 6 so that he can reach the last cell of our board. Okay, player 1 still outside. Okay, congratulations, player 2. He got a 6. Now he will be advancing from cell 16 to cell 22, and he got a bonus chance also. So let's use his bonus chance. Okay, bonus chance. So player 2 got a 4. So, is it possible to go further? There's two. Okay, yeah. Player two token will go out of bounds, which means adding 4 to 22 will be 26, which will be like he will go outside the board. So, it's not a valid position. So, he has to wait till his next chance comes. Okay, player one turn. Player one still outside of the board. Sorry, we can't do anything about that. Okay, player 2 got a 6. Still invalid move. Okay, finally our player 1 has entered our board. Let's see, player 2 got a 4. No, not valid position. Player 1 got a 1. Okay, from cell 1, he will advance to cell 2. Okay, where is it is? Okay, now see here. He is getting the recommendation of shortest path of 925. 2 is the like current position and 19. Why it is recommending 19? Cause 9 or at 19 there is a ladder head, which means we have to find LH1, which means ladder head 1. So we have to find LT1. Here it is. So the shortest path is basically giving us information that the player should get a 5 in his next dice move so that he can land on cell number 7 and climb the ladder from cell 7 to cell number 19. Okay, to cell number 19, and after that, he should get a 6 so that he can reach the end point. So, minimum number of dice moves required at 2. This is the main feature which we have added in this book. Okay, player 2 got a 5, still outside the ball. It seems like it's now player one's turn to win the game. Okay, player 2. Okay, let's end this game first. Okay, here we go. Once again. Since the dice won't require an experiment, listen. So, so this was, so here was like this. Our code will end. Uh, uh, the the game will go on like this only. Okay, let me see. Uh, let's run this code once again and see the output. Let's run the code once again. That is 2. There we go. Okay, player one has entered the board. There we go. Player two got a two. Okay, since it's not a valid move. Now, player one got a two, so it advances from cell one to cell three. Okay, from cell 3, the recommendation he is getting is 23 and 25. Why 23? There might be a ladder. Yes, there is a ladder. LH1. So where's LT1? Yep, here it is. So the recommendation he is getting is to get a dice move 2 in his next chance so that he can land on position number 5 and climb the ladder from 5th cell to 23rd cell. And after that, he should get a 2 so that he can land on 25th cell. So minimum number of dice moved from his current position will be 2. Minimum number of dice rolls which he will be having from his current position will be 2. Okay, let's move further. So like this, the game will advance. Player 1 and player 2 will keep on playing the game until unless, and in the end we get a winner. So let me explain the code part to you. Here is our code. This is our main function. So in this main function, first we are running an infinite while loop so that for cause if to check whether the player is if what if the player what if the user like enters an invalid value. We are giving the choice to deliver from 1 to 6. What if the user enters an invalid value like 7? So in that case, until and unless he doesn't enters a valid value, the loop will go on and on. Okay. After that, here is the list. We have created the list for the board. And this is basically the dictionary so that we can store the locations. We can store the rows and column value, cell value one. Okay. And here we are creating the board. Let me explain how this board is created. Okay. Here's the code. How it is creating our board. How is this loop is creating? See, this suppose we are creating a 3 into 3 board. Okay, so uh, you can see over here that you can see over here that this thing, I mean this loop is directly like starting from our this cell. Okay, for if n is equals to like 4, we are creating a 5 into 5 matrix, but here I'm taking example of 3 into 3. So for range, it will be start from second row, which is this one. So from second row, it will start and it will move from second to first, then 0. So it will be going like this for the rows loop. And for the column loop, I have created this condition of if k modulus 2 is equal to 1 so that I can keep and check to create this kind of pattern, which is a snake and ladder game board pattern. Okay. So if k modulus 2 is equal to 1, which is like if it is an odd row. To check if it is an odd row, we are having k modulus 2 equal to 1. Okay, so for column range n minus 1 from there, it is a condition from range n, which will run from 0 to n minus 1. So 0, 1, 2. Since snake and ladder will start it like this 1, 2, and 3. And after that, it will this one loop will run from here to here. Yeah. This loop is like this, and this loop will create and store the value like this. So the first loop will store the value like this, and this one loop will store the value in our board like this, so that we can get a zigzag pattern in our snake and ladder board. Okay, so this is the functionality of this loop. Next, what we have is position snake and ladder. Here we are using a generate random snakes and ladder function. Let me show you this function. Generate snake and ladder function. Here it is. Yep. This function will randomly generate random number of snakes and random number of ladders depending on the size of our board. So the return value which we will get will be the random number of snakes and ladder, which will be directly passed to the position ladders and snakes. This function will generate snakes and ladder at random position. Let me show you that function also. Generate random snake position. I mean, okay, where it is. Yeah, here it is. See, here's the position ladders and snake function. We are taking the board. This is the loop for the number of ladders, random number of ladders or snake which were generated. Okay. Now, while true, we have created an infinite while loop condition. I will tell you why. Here, we are using a random library, a random module, I mean, which we have in Python, so that we can generate a random number from in the board. We can choose a random cell value of the board for the head and for the tail. This head row variable will get the random row value, and this tail row variable will also get the random row value for the tail of the snake or the ladder. And this head column and this tail column will also get the random column value for storing the head and storing the tail. Okay. Now here we are having an if condition to check whether the snake or whether the head and tail lies on the same column or same row. If it is, then in this if it is, then it is not good. So that's why we are using this exclamation this not symbol, like if head row to check whether the snake head and snake tail lies on the same cell or not. And we are also checking the condition whether the head position is not going out of the bounds. Okay. Next one, we are having the feature of len of board. So that this is basically a feature to check whether we have got the right value or not. Once we have finalized the value, we will just update it directly on our board. After that, we have like positioned our snakes randomly on our board. We'll be we'll be asking the user for the number of players who will be playing the game. Okay. Now this is the initialization part where we are initializing. Now this is displaying the board. Let's start our game. Now this is the refresh console part, so for clearing out our console, refreshing every time the player moves, so that there is no mess over there. While true condition over here. This is an infinite loop. This loop will run until and unless we don't get a winner of our game. See over here, we have created the for loop so that every player gets his turn. And now, if player position, this is the condition to check whether our player is positioned inside the board or outside the board. -1 here denotes that that our player has still not entered our board. So if this condition like satisfied that our player is still not entered our board, so we will roll the dice and we will check whether he has got a 1 or 6. If he has got a 1 or 6, we will let him enter the board. We'll update the position of the player inside the board. Now, if the case arises that if the ladder is present at the first cell only, so for that condition, we are checking over here that if ladder is present at the first cell only, update the position of the token directly to the ladder head wherever the ladder takes the token though. And here is the other, here we are using else that if it whether gets a 6 or not. Let me show you the ladder function that he climbs the ladder or not. Okay. Yeah. Here is the ladder found function. See, you can see over here that if the player gets a ladder, we are extracting the row and column of that player position, that current position of the player from the player position dictionary, and cell content. We are extracting the cell content which are of the board. Because every value in our board, every cell value of the board is actually a string, not an integer. I've used the data type string and for our board because so we can add a ladder, so we can update positions of the players and position of the snake and ladder directly in our main main list of our board, main matrix of our board. Okay. So cell content, we are extracting the cell value of that location where our player is present, where that ladder tail is present. Okay, now here we are splitting the ladder tail value minus L2, like for example, let me show you this. For example, first cell, comma, LT1, comma, T1. Okay, so here we are using the split. A split will split this thing into two parts, minus LT1, minus LT. So here it will be splitted. So this one will help us to get this part of the split, this part of the list, and zero will help us to get the first character of this list. Okay. So after getting the first, we are getting the which ladder. We will get the ladder number. That which ladder is he referring to? Which ladder he has landed on. So we will search for that ladder head in the board. This loop is basically searching for that ladder head inside the board. After we get that ladder, we will store the row and column value of that ladder. Here, this complete line is actually updating the location of the player on the main code or on the main matrix. So here it is just a message that you are moving from this cell to this cell. Coming to the part when the player enters inside the board. Okay, when the player enters the board, we will just run. We have this function inside board. Let's check out this function. Yeah, when the player is inside board, we will roll the dice. Now we will add this dice value to the player's current position. If the dice value is like if the dice value is 1, which is the required value for the player to exit the board when he reaches the last cell. So if the dice value is 1 and the new position is like just one more than the last cell value, then we will return that this player is the winner of our game. After that, LF, we have created this condition of new position is less than equal to good, so that to keep a check whether the new position doesn't exceed the limit of the board. For example, if your player is position at 23rd cell and your dice value takes him to 26th cell and your board size is just 25. So for that, we are checking that he doesn't exceed the board limit. After that, if he is within the board limit and he has still got some moves to go, we will check whether the dice has got a 6 or not. If it is a 6, then we'll give him a bonus point. And after that, since it's a valid move, so we'll advance him to that new position cell. After advancing him to the new position cell and updating it in the main matrix, we will check whether that new position is having a ladder or not. And if there is a snake or not. If there is a ladder, we will advance him to that ladder head, and if there is a snake, we will advance him to the snake tail. The snake, the code of updating the ladder and position in ladder and snakes cases is exactly the same. Only the name is changed. That here it is LT and it is SH. Okay. Now, after we have like updated the position, we will check for the bonus points. If the user has got any bonus chances, we will let him use his chance and we will give him the chance to roll the dice once again. So after rolling the dice, there comes the main part of our board, which is the shortest path. Now, coming to the shortest path, we will this is the function for finding the shortest path. Here comes our main part of our code. Let me explain you with a diagram. There we go. In the shortest path, we are using BFS algorithm, which is breadth first search algorithm. Why we are not using BFS algorithm? There's a difference between BFS and BFS. See, the difference is suppose you have to go from cell, you want to find the shortest path between cell 1 to cell 5. Okay. If you are using a DFS, Okay, if you are using a DFS, DFS is actually depth first search. It actually traverses for diagram like this. Leave 5. Let's say we want to go from 1 to 4. Okay, so this is 1, this is 2, this is 3, and this is 4. Now we want to find the shortest path between from 1 to 4. If you are using a DFS, then it will do a branching. So like one from 1, you should go to 3. It will in the first iteration, it will see the neighbors. Okay. After that, it will like do further branching of like two from 2, you should go to 3, then you should go to 4. Like this, you can go. Okay. Or if from 2, you can directly go to 4 and directly go to 1. Okay. And if you go to 3, then you can directly go to 4. And if, wait a minute, one minute. This is written, I think. Okay. 1 to from 1 to 4, this is good. So it will in the end recommend that this is the shortest part. But what about this part? What about this part? Isn't this the redundant thing which we have done? Isn't this the extra thing? That's the main thing which I am saying. So this is the difference between a BFS and a DFS. So if we use a BFS algorithm in BFS, the BFS doesn't traverse to the node which he has already traveled. Okay, so if it's like 1, it will locate the neighboring cell values from 1, 2, and 3 and 4. Okay. Now he won't check, he won't go further because 3 is already traveled. He won't go to 4 because 4 is already traveled. He won't go to 4 from 3 because it is already traveled. So in the end, it will automatically recommend that that 1 to 4 is the direct shortest path. So we are using the same algorithm over here also in of BFS. You can see over Q, we are using Q collections. We are using Q over here so that we can easily pop out the other values which are not the shortest path. Here we are running a loop for the Q. Q is actually basically holding say, this Q is like this. Yeah. It is like this. This part will comprise of the complete path of the shortest path, and this will comprise of the current location of the queue. Let me explain you with an example. For example, let's say, okay, first, okay, there. For example, like one from position 1 to 2 in the first iteration, your queue, for example, if you are going from position 1 to 2, if there's a like 1 to 4 position, then if you run the loop in the first iteration, the what values will be stored in the queue? It will be like 1, comma 1. This will be the position values in the stored in the queue in the first iteration. And if we go for the second iteration part, after the first iteration is completed, this is like the default value. This is the default which is stored in the queue. Okay. And after the first iteration is completed, the updated queue value will be comprising of the because it has gone through the 2, then 3, 2 to 3. Okay. Then so it's comprised of the journey of 1, comma 2, comma 3, comma 1, comma 3. Okay. And then it will for the fourth, for if from the dice value it gets a new position of 4, and then fourth is the last thing. And for the second iteration, the Q value will be like for the second iteration it will be Q is equals to the cell value will advance to 3, 1 comma 2 comma 3, and there we go. For from the second position, it will get the position, but the 3 is like already traversed, so this will not be considered. So we will remove it. And for the third, when it reaches the third location, it will be seeing that fourth is already traveled. So it will pop out this value also, and only this value will be remaining. So this will be considered as the shortest path. Okay, so there we go. This is the complete code of the shortest path. Here we are like checking if current value is equal to, we are extracting the first whatever value is present in the queue. After that, if current is equals to end, which means like if we have reached to the end point of traversing the whole board, then we will just return the path of the complete loop. And here we are checking whether if there is a snake or where there is a snake or a ladder. If there is a snake or ladder, we will traverse that path also, goes through the snake and goes through the ladder also. So this was all about how I created the snake and ladder code. You can refer to this code from, you can I will be posting the GitHub link for this code. You can refer this code from that also. I do understand each function very deeply because there is a complete definition for the code. This is actually a 270 line code, so it would be good. Thank you for watching. If you like the video, do like it and subscribe to the channel if you want further projects. Thank you.